This is Reginald from CTC. He will be showing us a single-phase capacitor start motor, and we'll take it apart so that we can view the different components. Let's start by dismantling the motor to see what's inside. We start by removing the drive end shield. Already, we can see the copper wires that form the stator windings. Next, let's remove the fan cover. Here we can see the fan. It is used to keep the motor cool while running. Now, we can take the non-drive end shield off. With the non-drive end shield off, we can remove the entire rotor from the motor. The rotor fits inside the stator, but no electrical connection is made between the two. Let's go through each part of the motor and explain its construction and function. The part of the motor that is most visible to us is the stator. This is the part of the motor that does not move. It is stationary. It is often also bolted in place. Inside the stator are coils of insulated copper wire called windings. These become electromagnets when current is passed through them. The windings are arranged and connected in series in pairs. In single-phase motors, there are two sets of windings: the start winding and run winding. The start winding has fewer turns and is made from slightly thinner copper wire. This means that the start winding has a slightly higher resistance than the run winding. The windings are wrapped inside the grooves of laminated plates that are fused together to form a core. These plates are usually made of iron and help to concentrate and strengthen the magnetic fields generated by the windings. The reason laminated plates are used, rather than a solid core, is to reduce the effect of eddy currents in the core from reducing the strength of the magnetic fields. The other crucial part of the motor is the rotor. It is the piece that rotates inside the stator because of the magnetic fields generated in the stator. Most single-phase motors have a squirrel cage rotor, so called because it resembles a hamster or squirrel cage in design. The bars or rods of the rotor are arranged inside the grooves of laminated plates, much like the windings of the stator, and are also used to increase the strength of the magnetic fields, this time induced on the rotor. All of this is fused together onto the rotor shaft. As we can see, the rotor fits snugly inside the stator and rotates within it. But remember, there is no electrical connection between the two. Now let's have a look at the other parts of the single-phase motor. The fan cover provides protection to and from the spinning fan blades. The fan, attached to the rotor shaft, spins to keep the motor cool during operation. The centrifugal switch is used to disconnect the start windings once the motor reaches about 80% of its rated speed. This is the rotor, which we have covered. The nameplate provides important details about the motor and its operating parameters. The non-drive end shield protects and seals the non-drive end of the stator. Non-drive end bearings help the rotor to spin smoothly. The capacitor is used to help start the motor. The drive end bearings also help the rotor spin smoothly. And the drive end shield protects and seals the stator on the side of the motor where the mechanical load is attached.